And hello there YouTubers, it is Collected5 with another video. This time I will be talking about computers of the future. Now, if you have seen the video I've done about what happens after we die, then you will probably have a faint idea of how computers work, or if you are a computer scientist, well, I am glad you're watching my channel, first of all, and you will know what a computer is, obviously. Anyways, um, how they work. Let's first talk about how computers work. Computers run on something called binary code, which means that the areas of silicon inside of a processor, they turn on, which is a 1, and it turn off, which is a 0, and those two digits make up everything you see on your computer. It turns into a code, sort of like Morse code, but not sort of like Morse code. It's hard to explain, but it turns into a language, just like how the English language is every combination of 26 letters. Everything you see on the computer is a combination of, well, zeros and ones of two digits. Anyways, as you know, there's going to be massive amounts of code that requires one picture or a video. Now, let's see. In the future, we have gotten to well, not in the future, but right now, we're researching types of computers that require only one atom to turn on a positive charge, or to charge, in order to create a 1, and only one atom to create a 0. Now, this may not sound particularly interesting, but what the great thing about this is the size. We could create computers the size of a strand of hair. One strand of hair. I mean, I'm talking not length, but width. The same width as a strand of hair. We could create a computer that wide that can be much, much more powerful than that old Dell that your mother had. Anyways, um, so it's incredible because size is probably one of the most important things about a computer. The bigger the size, the more you have to cool it, which is bad because it can cause a fire and it could melt itself. The smaller the computer is, the less heat it generates, no matter how much processing power it has. Now, the amazing part about this is that, well, it's okay to have a small computer, but what if something breaks, or what if one of the atoms is misplaced or loses an electron, or it's sort of compromised, so to speak. Well, that would be hard to fix, and that will be very painful to pay for. Now, instead of doing that, what we could do is create a quantum computer. This hasn't, like the normal computer, has a upsides and downsides. Um, computer. First, let me tell you about quantum mechanics or quantum physics. The difference between regular physics and quantum physics is that in physics, you could be in one place or you could be in another place, but you can't be in both places at one time, obviously. In quantum mechanics, you could be in one place, you could be in another place, but you could be at two places at once. So imagine me and another version of me sitting right next to me at the same time. That's basically what quantum mechanics allows you to do. Now, this may seem a far-fetched, and that idea is, well, um, nearly impossible, but on small levels and at small or very low temperatures, it can be possible. Now, I'm not saying low temperatures like going to the Arctic Circle, but by small temperatures, I'm talking about almost zero, absolute zero. Uh, if you don't know what absolute zero is, well, there is a form of temperature measurement called Kelvin. It goes from 0 degrees Fahrenheit Kelvin to 100 degrees Kelvin, or about negative 32,000 degrees Fahrenheit to positive 80,000 degrees Fahrenheit. No, sorry. Yeah, positive 80,000 degrees Fahrenheit. Now, absolute, which is, well, it's a big range. Now, absolute zero is the point at where, um, no, there's no energy. No energy exists at 0 degrees Kelvin. Now, the problem with this is that it's impossible to reach 0 degrees Kelvin because no matter what, you will always have energy, no matter where you are in the universe. Even dark energy has energy. It's just dark. Anyways, yeah, if the universe exists anywhere, that means that there's energy everywhere. So it's kind of impossible to have 0 degrees Kelvin. Now, um, let's see, if you were to cool down a silicon tab into almost 0 degrees Kelvin, I'm talking about like 1/100th of a degree Kelvin, which we have done, and it has that one point where we have, well, that piece of silicon would be the coldest thing in the universe, or at least in this area of it. Anyways, so we cooled down a piece of silicon. That not we, not I, but someone cooled it down. I'm guessing not JPL, but some other guy. I think it was in Wisconsin. Don't ask me why. Anyways, he cooled down a piece of silicon down to that slow temperature, and he created binary code that had a third digit, which is both 1 and 0, which he called a flat. Now, this may not seem very particularly interesting, but the two-digit code of a regular computer could has, well, four possibilities. Two-digit code in quantum mechanics has six possibilities. Any mathematician would know this. However, the great thing about this is that it's exponential. So what I'm talking about is, now get to the interesting part. Yes, I will. Well, a movie. Let's say a movie that, let's say, is 10 gigabytes can be stored down to the quantum equivalent of 10 or 1 or 2 megabits. That's amazing. And now that not only does that increase the speed of the quantum or of the storage unit, but it also it's you could increase the amount of storage you have. So for example, is that, let's say, you could have a micro SD card that could store thousands and thousands of terabytes of information. If you don't know how much that is, thousands of terabytes, imagine taking a 1 hour long video every day for the rest of your life. That's about 365 hours a year. Multiply that by, let's say, 80 years. That put together is about 1,000 terabytes. Multiply that by, let's say, another 1,000, that's about 1,000,000 terabytes. That could be stored in a micro SD card. That's about the size of your thumbnail, or your pinky nail, like that. Yeah, that's amazing. I mean, sure, there's a downside that, well, you have to have a refrigerator the size of a building in order to cool it down to 0 degrees Kelvin, but we might actually be able to fix that later, because, well, I mean, we could shrink things down, because we have been good at doing that. I mean, shrinking appliances down. Yeah. Anyways, there is a really good episode of how we get to not how. Wait, what? No, there's a really good episode with David Pogue. It's a PBS episode. Link in the description below. It's a very good show. I recommend you watching it. It's called Making Things Smaller, and or Making Things Smarter. And it takes computers down, and that's takes computers down to, well, incremental portions, and, well, they made a computer that was very small, and that's just how it works. Anyways, so that will probably the main computer that we could be using in the future. And what would we be using it for? Well, we could use it to find the answer to the meaning of life, which is, something that we've been pondering for a long time now. It'd be nice if we get the answer. Yeah. What else could we be doing? We could be answering some weird questions, solving unbelievable mathematic equations, and yeah, just boring stuff like that. Nothing really that exciting for normal people, but for me it's really exciting. So I hope they get the quantum computing things done. Now, quantum computer is not something that you would buy at any Best Buy. Actual quantum computer costs about, I think, $20 million. First, the refrigerator costs a lot, and then you have to buy the computer itself, which also costs a lot. Not as much as the refrigerator, though. Refrigerator costs a lot. Anyways, so yeah, that's basically it for this video. Please visit the link. It's very good. Um, that's all I could say. Hopefully in the future, hopefully in my generation, we will have quantum computers. I mean, imagine gaming with a quantum computer. Like, we'd have 10K, 5,000 FPS. Stuff of dreams, man. Anyways, yeah, please, if you like this video, please hit like, subscribe, stick around for more. there's not really much more I could say. Uh, I'm, I mean, it's just an amazing phenomenon that we could actually create a quantum computer. So that's stuff of dreams, and that, well, until recently, quantum mechanics has been thought of as a theory and not have and has not been proven true. Anyways, that's about it. Please thanks for watching. Hit like, subscribe, and I hope to see you in my next video.